So today we are going to look at combining resistors. So we're going to do a few practicals and then we'll hopefully get to the theory at the end of it as well. So we're on to this page, which in my notes it says page 7, but I think it might be page 5 for you because you've got 2 page 2s at some point. But it should look like that. Everybody got the right page? Okay, so we're going to do, well, 3 different experiments. 2 of them are basically the same experiment. So we're going to start with combining resistors in series. So we're going to use these ohmmeters again that you used to start this booklet. And remember, when we're measuring resistors, we don't actually need to have a power source connected into it. You can see the circuit diagram there. You've just got the ohmmeter and you've got 3 resistors in series. A reminder about how to set that up. I'm not going to set it up in front of you. I'll just show you the picture because I think you're pretty confident setting things up, especially in series. So there we've got our ohmmeter and we've got some resistors in series with each other. So it's one of those ones where it's all one big loop, all holding hands in a circle. A reminder about your ohmmeter. To connect this up, it should be connected to the black COM. That it always gets connected to that no matter what you're measuring. And then the one with the ohm next to it, which is the bottom one here. So these 2 connectors there. And then a big loop for series. So for this experiment, go back to notes. What you're going to do is, first of all, you need to measure the resistors individually. So you just plug one resistor in to this, measure what the resistance is, write it down here. Get another resistor, measure what it is individually on its own, write it down there. A third resistor, measure what it is individually on its own, write it down there. Okay? Then you put them all in series with each other and measure the total resistance of all 3 of them, and you write that down there. And hopefully we should see a pattern emerging where the sum of all of those is equal to what you measure the total of. So you're measuring them each individually, writing it down, then you're putting them in series and measuring them in total. Not adding them up, but it should be equaling around the addition of them all. So this one's a relatively straightforward one. You have 4 resistors on your deck. I'm going to come around with one extra one as well, so you can have a number of combinations. So you could have G, H, and F, then you could have F, H, and what are the other one is J? Yeah, and there's also D as well to throw in the mix there. So you've got lots of different combinations you can make with 3 different ones. You could have, even if you want to, and this is, Corbyn's rules, you might need to whack it down afterwards. You can grab another one, so you can have 2 H's and a G or whatever if you want to do that. Okay. Right, any questions from that one? Relatively straightforward. So get a few different combinations and have a go at filling in the conclusion, and then we'll talk about the next one. So I just made up some results there. I didn't actually measure these, but this is what you're kind of looking for. So your individual resistors, I had 1, 7, 115, and 122. My total measured resistance, so my actual experiment gave me 42. If you add them all up, it comes to 44. So it's around about the same, so which is good. Same with the next one, around about the same. Okay, you might lose some resistance. Some of the resistance might be added in from the wires and things like that. So as long as it's around about the same. So in conclusion, this is a nice, easy one. The resistances of a number of resistors in series is the sum of the individual resistances. And as a sort of equation for 2 resistors in series, RS, so the supply resistance, the total resistance or resistance in series for S is R1 plus R2. And if you had 3 resistors in series, it would be R1 plus R2 plus R3. If you had 4 it would be the sum of those. If you had 5, it would be the sum of those. Okay. So the examples of these are nice and straightforward. You just need to watch your units. Come on. So find the resistance between X and Y for each of the following arrangements of resistors. So between X and Y means the total resistance between here and the total resistance between here. Now, just be careful with your units for these because you've got 4.7 kilo ohm and an 820 ohms. So you need to make sure they're both sort of the same units. So you could change one into you could change them both into kilo ohms and then have your answer in kilo ohms. Easiest way I think is to change it into ohms. So RS equals R1 plus R2. Get in the habit of writing the equation just in case you put the wrong numbers in. So 4,700 ohms plus 820 ohms. And that comes to 5,520 ohms. Okay, so the most difficult thing about this is just making sure your units are correct. So for question 2, you've got 2.2 mega ohm, 47 kilo ohm, and 220 kilo ohms. So up to you what you change it into. I would recommend just changing it into ohms just for simplicity. So 2.2 mega ohms is, if you want to use, so you do your equation RS equals R1 plus R2 plus R3. You can either go 2.2 times 10 to the 6, or it's 2,200,000 plus 47 kilo ohms, so 47 times 10 to the 3, plus 220 kilo ohms, so 220 times 10 to the 3. I suppose you could have changed them all into kilo ohms, and then that would have just been times 10 to the 3. But whatever you find easiest in terms of units. And I believe the answer comes to 2.5 times 10 to the 6 ohms, or 2.5 mega ohms. What I'm going to do is I'll write it down underneath just in normal numbers. So it would be 220,000 plus 47,000 plus 220,000. And that would come to you, if I rounded it, if you find it easier thinking in terms of that, but I would recommend getting used to using your times 10 to the 6, times 10 to the 3s. As I said, easy is just adding up, but just make sure you watch those units. Because it's so easy, I tend to just chuck some extra units in there just for you to do. Everyone happy with that? Okay. Next experiment we're going to do is similar thing, but in parallel this time round. Am I okay to move on? Is anyone still writing? Give it a little bit. So for the second experiment, we need to do the same thing, similar thing again. So we need to measure each one individually, and then we're putting them in parallel rather than series. So if you have measured them all individually already, and you've labelled them, so I know Charlie was doing it because I said that was quite a clever way to do it. So he did like F, G, J, and then he measured out each one individually. So you already know which one they are individually. You can use those. If you don't, just measure them all individually at the start anyway. Right, so resistors in parallel. So this is two separate experiments in one, basically. So you can either do 2 resistors in parallel or 3 resistors in parallel. So if you look at the results tables, there's 2 separate results tables there. There is R1, R2, total measured resistance. So that's individual resistance of resistor 1, or F if you want to do. Total individual resistance of resistor J. Hear me? Come on. then your total measured resistance. Now, to set it up in parallel, you've got these photos as well, so don't worry about this. You, again, don't need a power supply. You get your ohm meter, and you go from the same two connections into the first resistor. Then you double up on that first resistor and go into your next one. And in the 3 resistors, you do the same kind of thing, but you double up again and go into the third one. So you're sort of doubling up on each resistor until you get to the final one. These pictures are in your boxes, you can go back and revisit them. So what we're going to do is we are going to measure the resistors individually, then measure them when they are in parallel with each other. That's your measured resistance. Okay. Now the rest of this table is doing calculations. So that is 1 divided by R1. So I'll just do examples here just so you can see what I mean by that. So if I say I use 22 and 10 for my individual resistances, my total measured resistance will be, spoiler, it'll be less than that. So I think I did this and I got 7 for my total measured resistance. Okay, so 1 over R1 is 1 over 22. You don't need to write in the working out, but I've just done that anyway. So 0.05. 1 over R2 is 1 over 10, which is 0.1. 1 over R1 plus 1 over R2 is that plus that. So 0.15. And 1 over RP means 1 over this one here. So if I just go in and label that RP, it's 1 over 7, which is 0.14. Okay, so there's quite a lot to remember for this one. So this is your measurement. Then you're doing calculations. So if you want to just do the measurements first, then some math calculations, that's fine. But we're looking for, ideally, these two to be equal to each other. So I'll do another example here. So if I had 10 and 7 for my individual resistances, my total in parallel would be about 4. So 1 over R1 is 1 over 10. So that's 0.1. 1 over R2 is 1 over 7, which comes to 0.14. Add those together, 0.24. And 1 over RP, 1 over 4, which is 0.25. Okay, does that make sense? It's quite complicated, practical. Once you've done the 2, you can move on to 3 as well, which is even more complicated. Right, off you go, have a go. Right, okay, everybody. As I said, don't worry if you don't have the full table filled in, as long as you got a couple of rows. Okay, and listen. Right, so conclusion. So what we're seeing here, or we should be seeing, if you've got your math right, is 1 over resistor 1 plus 1 over resistor 2 is equal to 1 over the total resistance in parallel. Okay, so in conclusion, in words, the inverse, that means 1 over, of the resistance of a number of resistors in parallel is the sum of the inverses of the individual resistors. So, easier to understand if we put it down in an equation. For 2 resistors connected in parallel, 1 over RP, so the total resistance in parallel, is 1 over R1 plus 1 over R2. And for 3 resistors in parallel, 1 over Rp, so 1 over the total resistance in parallel, is 1 over R1 plus 1 over R2 plus 1 over R3. So even if you got those tables, if those tables went wrong, these are the important equations that you're going to use. Okay? So, for example 1 here, find the resistance between X and Y, so the total resistance there, for each of the following arrangements of resistors in parallel. So the first one, we've got two 12 ohm resistors in parallel. So we're going to write down our equation, 1 over Rp, so 1 of the total resistance in parallel, is 1 over R1 plus 1 over R2. So 1 over Rp is 1 over 12 plus 1 over 12. Okay. Now this is where your calculator comes in handy. You could do it in your head, you could change all your numerators and denominators and things like that, but I would recommend just doing it on your calculator. So 1 over 12 plus 1 over 12 is 1 over Rp. So 1 over Rp is 2 over 12, but if you put that into your calculator, it'll probably simplify it to 1/6. Now that's not our final answer because that's 1 divided by the total resistance. To find your final answer, you flip it over, or you do 1 divided by answer in your calculator. So 1 divided by 1/6 is 6 ohms. As you can see, you can just flip it over if you remember that, but if you don't, you just do 1 divided by the answer in your calculator. Okay? Have a go at question 2. What's your unit? So at least put all the numbers in, make sure your units are all in the same unit. So I would change them into ohms. I would recommend using your calculator, but if you're good with fractions, feel free to do it. Find your common denominator. Yes, Felix. So, get your calculator. So 1 divided by 2000 plus 1 divided by 1,000 plus 1 divided by 500, it might come to that's the same, it's the same, so don't worry about it. Okay, everybody, let's go through this. So, for this one, 1 over RP equals 1 over R1 plus 1 over R2 plus 1 over R3. Now, let's put them all into the same unit, so I'm going to go for ohms. So 1 over 2,000 plus 1 over 1,000 plus 1 over 500. So that in total comes to 7 over 2,000, or if you put it into a calculator, it might just give you it as non-fractions, that's fine too. But that's not the final answer, that's 1 over RP. To find RP, you have to do 1 divided by your answer, or flip it over and then work that out. So 1 divided by our answer should come to 286 ohms. Don't worry, you're going to have lots of practice on these. And the last one is the trickiest one. Leave that up for a second. Feel free to have a go at the last one, but it's resistors in series and parallel. So you're going to have to calculate your parallel ones first, then you add it to the one that's in series. But I will go through it. I'm just going to leave that up for a second. Okay, let's go through this last worked example. So we've got 6 ohms, and that is in series with 2 that are in parallel with each other. So the first thing that I want to do is work out what that total resistance is of those 2 in parallel. So if I say 1 over RP equals 1 over R1 plus 1 over R2. So 1 over 12 plus 1 over 18. And that's 1 over RP. So 1 over RP, that would come to 536 in your calculator if you've got it in your in fraction mode. So RP is 1 over the answer, which should come to 7.2 ohms. So that's not your final answer. Shouldn't be talking over me. That is just that value there, 7.2 ohms. So we've now effectively got a 6 ohm resistor in series with a 7.2 ohm resistor. So the total resistance, so R total, equals 6 plus 7.2. And that is 13.2 ohms. So the total resistance between X and Y is 13.2 ohms. Okay, so these are relatively tricky questions, so we'll have plenty of practice on these. But please do let me know if you're struggling with these or you need any extra help with them. But I think once you get going, you sort of get used to them. I think people who do engineering science will know that you do lots of practice, it become sort of like second nature to you. Right, I'm not going to continue with any